Hey guys, how are you all? So today we are going to discuss the physical properties and chemical properties of carboxylic acid. So the first thing, the physical property, aliphatic carboxylic acid up to 9 carbon atom are colorless liquid at room temperature with unpleasant odor. Okay, so C1 to C9. If it carbon 1 to 9, that is your colorless liquid. The higher acid or wax like solid are practically colorless due to low volatility. Carboxylic acids are higher boiling point liquid than aldehyde and ketone. Okay, if you are comparing the aldehyde and ketone, your carboxylic acid will be more boiling point. Okay, so even alcohol's comparable molecular mass. Okay, so even we can compare the alcohol also, right? So compared to alcohol also, your carboxylic acid going to be more, right? So next, this is due to more extensive association of carboxylic acid molecule through the intermolecular hydrogen bonding. The hydrogen bonds are not broken completely even in vapor phase. In fact, the most carboxylic acid exists as a dimer in vapor phase, okay, or in the aprotic solvent. So simple aliphatic carboxylic acid having up to 4 carbon atom are miscible in water. Okay, so C1 to C4, the carbon number 1 to 4, it is miscible in your water molecule. Okay, then the formation of hydrogen bond with that, the solubility decreases with increase in number of carbon atom. So if it CH3 COH, this is 2 carbon, right? So this is methyl. Okay, it become a ethyl, it become propyl, it become a butyl, it become a pentyl. At the time number of carbon get increases, right? So that alkyl group number of carbon get increases, then it will repel with water. It repel with higher carboxylic acid practically insoluble in water due to the increased hydrophobic interaction, hydrocarbon part. So this is, we are moving from the ethane to pentane at the time. So hydrophobic in nature increases, at the time the solubility also decreases. Clear? So carboxylic acids are also insoluble in less polar organic solvent like benzene, ether and alcohol and chloroform. Okay, in this solvent the benzoic acid will not dissolve, right? So next, there is a chemical reaction in carboxylic acid. So I want to give the brief about this. So I'm taking the one acid. Okay, I'm taking the one acid. In that, what are the way the reaction going to be, I will explain to you. Okay, what are the way the reaction it is going to be, right? So I'm taking the 4 molecule. So 4 molecules, the same molecule only, the 4 are same molecule only. So in this, right, your first reaction, the first way of the reaction in the carboxylic acid is the near to your carboxyl group there is hydrocarbon is there, right? In that the substitution reaction is take place. So this reaction is Ewald-Zielinski reaction. Okay, this is first reaction. Then the next reaction is there is a reaction in the carboxyl group like reduction or decarboxylation. Okay, these are the reaction in the carbonyl group. Okay, so in case of here there is a breaking of bond between carbon and oxygen. Okay, the third way of reaction. The fourth way of reaction is the breaking of bond between oxygen and hydrogen. Clear? So the first one is there is a cleavage of bond between OH. So we know that if you are comparing the your alcohol and carboxylic acid, if you are compare the your alcohol and carboxylic acid, your carboxylic acid is more reactive towards the base compared to your alcohol, right? So here it is given. So the carboxylic acid like alcohol evolve hydrogen with electropositive metal from salt, form salt. Okay, so when alcohol react with metal, it form the salt and with alkali similar to phenol. Okay, however, unlike phenol, they react with weaker bases such as carbonate. So hydrogen carbonate evolve the carbon dioxide. This reaction is used to detect the presence of carboxyl group. If I am taking the your phenol, if I am taking the your carboxylic acid, if you are compare, so this two react with the sodium electropositive element and the base, okay, but this also react with the sodium and sodium hydroxide, but in this case the your phenol will not react with your sodium carbonate, okay, or sodium bicarbonate, okay. So both way, the both with both molecule it will not react in case of phenol, but in case of your carboxylic acid, it react with the sodium carbonate and react with your sodium bicarbonate. Clear? Right. So it react with your carboxylic acid. So Na, there is a formation of sodium carboxylate and hydrogen. Okay. So here the carboxylic acid NaOH is there. It going to give the your salt and water molecule. Okay. So if you want me to briefly explain this, so I will explain here. First I will write the your Na plus and OH minus, right? So here CO minus H plus. So OH minus connect with H plus, it form the water molecule. This Na connect with CO minus, it become a salt. Understand? In case of sodium bicarbonate also I will explain. So here there is a hydrogen. So this hydrogen react with this OH. So this form the water molecule, okay. Then there is a C double bond O, then there is a ONA, okay. So this Na going to connect with your COO, so it give rise to COONA, H2O and CO2, okay. So here also there is a carboxylic acid, okay. If it involve reaction with water, so your carboxylic acid is acidic one, your water is act as a base, so your base abstract the proton, it become a hydronium ion, so it will lose the electron, lose the proton, so it become a carboxylate ion. In this carboxylate ion, your negative charge, okay, the negative charge of the negative charge, okay, remain over your more electronegative element of oxygen. There is a two equivalent resonance structure. This is very important, okay. The carboxylate ion which has the two equivalent resonance structure, very important, okay, right. So look here, in this they given they are comparing the acidic character. If you are less than 1, your pK value is less than 1, that is most acidic. So if it pK value 1 to 5, the moderately strong acid. So if it more than 15, at the time extremely weak acid, okay. So carboxylic acid is weaker than mineral acid, we know, right? Okay, so say for example, if I am taking your acidic acid, your mineral acid is HCl. If you compare the strength of the acid, your mineral acid is always more compared to your organic acid, okay. In fact, the carboxylic acids are almost most acidic organic compound you have studied so far. You know, whatever from the first line, all alkane to allenes to your carboxylic acid, your carboxylic acid is most acidic one in your organic compounds, okay. So you already know why phenols are more acidic. The higher acidity of carboxylic acid as compared with phenol can understood similarly, okay. So the conjugate base of the carboxylate acid stabilized by two equivalent resonance structure. This is very important, I already told you, okay, in which negative charge is at more electropositive oxygen, okay. If I am taking the carboxylate ion, so your negative charge over the most electronegative element. If it one more structure also, the negative charge over the oxygen only. Am I right? Right. So the conjugate base phenol, the phenoxide, has non-equivalent resonance structure, okay, in which the negative charge is at the less electronegative carbon. So look here, if I am taking the your phenoxide ion, one structure the negative charge is over the oxygen. In another structure, if you look here, in another structure, if it become a double bond, at the time the negative charge will come here, okay. So if now the negative charge over the carbon is less electronegative compared with your oxygen, that is more important. So therefore the resonance in phenoxide ion not as important as it is in the carboxylate ion. Further, the negative charge is delocalized over two equivalent oxygen atom. two equivalent oxygen atom in the carboxylate ion, whereas it is less effectively delocalized over one oxygen atom, less electronegative carbon atom in phenoxide ion. So thus the carboxylate ion is more stabilized than your phenoxide. This is very, very important. Your carboxylate one is more stabilized one compared to your phenoxide one. Now if there is a acid I am taking, okay, if there is a acid I am taking, okay, so in that if there is a electron withdrawing group is there, electron releasing group also possible, electron releasing group, what it going to do is electron releasing group going to destabilize, okay, electron releasing group going to destabilize the carboxylate ion. At the time the acidity get decreases, but in case of electron withdrawing group going to stabilize your carboxylate ion, at the time acidity get increases. Okay, so again one more time I will tell you. So your electron withdrawing group can stabilize your carboxylate ion. At the time your acidity get increases, but in case if it electron releasing group is there, it going to destabilize your carboxylate ion. At the time acidity get decreases. Clear? So this is the effect of following increasing order of acidity. Okay, so we will compare. So here fluorine is there, your chlorine is there, here 2 chlorine is there, your NO2 is there, your CN is there. So 3 fluorine is there, so this is going to be more acidic. Then 3Cl3 is there, then this is acidic. This 2Cl is there. If it 2Cl and 1 NO2 is there, 2Cl contained compound is more acidic. Okay, for the look here, some of the order which is given here, we know that, right? The fluorine is more electronegative compared to your chlorine. So then your bromine, then here the formic acid there, but this one is propanoic acid. Okay, so here the distance between your electronegative element and the carboxylic acid is longer, so this one is weaker acid compared to all other acid in the order. Okay, so in case here this is benzoic acid. In the benzoic acid, this is minus A effect, this is also minus A effect, but this minus A effect present in the carboxylate carbon itself. Okay, but in case of here this carboxyl group, the CH2 is in between is there. That is the reason why this is more acidic compared to this one. Then if you are comparing this 2 acid with this 2, at the time it has the electron withdrawing group or minus I inductive effect. Okay, electron attracting group is there, so this 2 is more acidic compared to this 2. So as I told you already, if it number of carbon get increases, at the time acidity also get decreases. Okay, so direct attachment of group such as phenyl and vinyl in the carboxylate acid, so increase the acidity corresponding carboxylic acid, contrary to the decrease expected due to your resonance effect. Okay, so this is because electronegativity of sp2 iodized carbon, which is electronegative carbon to which the carboxyl carbon is attached. Okay, presence of electron withdrawing group on the phenyl aromatic carboxylic acid also increase the acidity. We will discuss it. So then we are here, so this we are going to discuss. Okay, so this is electron releasing group, this is neither electron releasing nor electron withdrawing, this is electron withdrawing. So this is A, this is B, C. Okay, so your least acidic one is A because electron releasing group decrease the acidity. So here neither losing neither gaining of electron here. So your A is least acidic, then B, then C is most acidic because of presence of electron withdrawing group. So electron withdrawing group stabilize the carboxylate ion, so increase the acidity. Okay, clear? So then this is the dehydration. Okay, dehydration reaction. The formation of anhydride is here. Okay, look here, formation of anhydride. If I am taking the 2 acid, one acid OH group, another acid hydrogen, so together we are taken as a H2O. Okay, H2O is your byproduct, so we will get the acidic anhydride. Okay, when it comes to esterification, in an acid there is always removal of your OH. In your alcohol there is a removal of always hydrogen. So what it come? It become a minus H2O. So what it here? C R C double bond O, then OR. Okay, clear? Right. So second thing again, the acid is when it react with PCl3, PCl5, SOCl2, we will discuss. Look here, so this is reaction with ammonia, it is next reaction. Okay, so this is reaction with PCl3, then PCl5, then SOCl2. Here the bond breaking is oxygen and carbon. Okay, so if I'm taking the PCl3 at the time, look here, so this is Cl, so this Cl going to bond with RCOCl, remaining one more hydrogen, one more Cl react with H, it going to form HCl, then remaining 3 Cl, it going to bond with this oxygen, it going to form a POCl3. So this is POCl3, this is HCl, this is ROCl. Then if I'm taking the 3 times of RC double bond OH, at the time what will going to happen is, if I'm taking the Cl, okay, so this are all bond with your phosphorus. So here 3 OH is there, right? So it become a H3PO3, right? 3 OH is there. So this 3Cl bond with ROCl, it is going to form the 3RCOCl. Clear? Right. So next reaction with ammonia, right? Next reaction with ammonia. So if it reaction with ammonia, at the time, this is your carboxylate act as an acid, carboxylic acid, your NH3 act as a base. So acid and base give rise to ammonium salt. At the time, if you are eating, at the time it leave the H2O and give rise to amide. Okay, so here also there is ammonium salt, then elimination of water, that is lead to formation of benzamide. So next there is one more reaction, it is there. Okay, so I will tell you how it is. Okay, the first I have to take the 2 times of NH3. Okay, NH3 bonded with hydrogen, it become NH4. So NH4, salt is, we got it. After that we are eating, from this one water molecule get eliminated, from this one water molecule get eliminated. So it become a phthalimide. Okay, so this phthalimide, this NH3, one more hydrogen is here, right? This become a NH3. So at the time your NH going to be there, one NH to get removed, then this like molecule is formed. Okay, so this we call it as a phthalimide. The phthalimide we are using preparation of primary amine in the amines chapter. We will do it later. Now your carbonyl group going to involve in this reaction. Okay, so the first one is your decarboxylation reaction. In the decarboxylation reaction, whatever the number of carbon acid is there, one carbon lesser than, okay, that is your product. Okay, so if I am do the same Kolff electrolysis we discussed in the your hydrocarbon chapter, so this get removed. Okay, so your double the number of alkyl group product is formed. Clear? Then I already told you there is a reagent which can reduce the acid is, one is lithium aluminum hydride. Okay, one is lithium aluminum, RC double bond OH is there. This can be converted into RCH2OH. Okay, for this what is the reagent we are using? B2H6 diboron we can use, lithium aluminum hydride. Okay, lithium aluminum hydride we can use it. Okay, this is very important. This two reagent only it can do the your acid to alcohol. Okay, right. Then there is a halogenation reaction is there. So already there is alpha carbon. In that carbon, hydrogen is get replaced by halide. Okay, what are the halide? Your chlorine and bromine. Yes. Okay, so any other reaction is there under that? No. Okay, everything explained. We will go for next. When it comes to here, look here. So if I'm take this, so before, so here is the reaction. So in this I will explain in this simple way. As I know, the COH group is electron withdrawing. Okay, if it electron withdrawing group bonded with your benzene, what will going to happen? At the time your ortho and para position, electron density get decreases. So the electron rich position is your meta position. So that is the reason why meta-nitrobenzoic acid, meta-bromo-benzoic acid. So there is a question which is there, 12.8. We will solve this. So here there is a 2 acids which is given here. Here CH3 is there, but in case of here CH2F is there. So F is more electronegative compared to your hydrogen. So your F contained compound is more stronger acid. Okay, so in case of here Cl is there and fluorine is there. Fluorine is more electronegative compared to your chlorine. So fluorine contained compound is more acidic. in case of here, both the places there is a presence of fluorine, okay, but in case here the second carbon from the carboxyl, the second carbon which contain the fluorine, but in case of here from the carboxyl, third carbon which has contained. So the electronegative group, if it present near to that your carboxyl group, that is going to be more acidic one, okay. So in case of here, this is electron releasing, going to stabilize, it going to destabilize your carboxylate ion, so decrease acidity. But in case of this one, electron withdrawing group, it is going to stabilize the carboxylate ion, so this is going to be more acidic. So next, uses of carboxylic acid, hexane diic acid used to manufacturing of nylon 6,6. We will discussed in the polymer chapter, okay. So ester of benzoic acid used in the perfumery, the sodium benzoate used as a food preservative, the fatty acid used for the manufacturing of soap and detergent, okay. This is the your last video on the aldehyde ketone carboxylic acid. Any doubt it is there, you can comment in the comment box. I will make separate video for that. Thank you all watching the video, okay. So till the time, make the next video. Bye bye, take care, do well in the your exam, okay. So all the best.